Okay, today we're going to be reviewing something that you should have learned very well in Algebra 1 that is going to be a very important part of what we're going to do in Chapter 5 as well as the remainder of the second semester as we go through some other chapters. Today we're going to be reviewing the process of foiling and factoring polynomials. Now, to start, this is going to require us to do a quick review of polynomials and learn a little bit of the terminology that you need to be familiar with as we move forward. So if we take a look here, as we start, we have a list of common types of polynomial functions that we're going to be dealing with, and we need to talk about the various parts to them. Now, each type of polynomial that we deal with has a specific name that goes along with it. So you can see in the type we have a constant function, a linear function, which we dealt with, and if you look at those two, these are basically Algebra 1 functions that you've learned. In Chapter 5 we're going to be dealing mostly with quadratic functions, and then we'll introduce the idea of a cubic and a quartic function to you later in the semester as we move forward. But before we get started with the very specifics, we need to talk about the different parts of a function. Now we have three different terms that you need to be aware of: the leading coefficient, the constant term, and the degree. Now, before we can figure these out, we need to be able to take the polynomial function and write it in standard form. So I'm going to just give you an example here. If I take a polynomial function like 2x squared plus 3x plus 1, this is a quadratic function because it is to the second degree. It is written in standard form because the exponents are in descending order. So let's take a look at all these parts. If we take a look at this, the leading coefficient is the coefficient in front of the initial term. So 2x squared is our first term of this polynomial. The 2 would be considered the leading coefficient because it's the coefficient in front of the first variable. Now, the degree here is the highest exponent. So remember, the degree is the highest exponent. And when we are finding the degree, if it's written in standard form correctly, it should be the initial exponent all the way to the left. And you notice that as you go down, they get less and less. Now, this degree indicates to us the type of function that it is, and the type of function for this case is a quadratic function because it has a degree of 2. So you can see that when it's written correctly, it's very easy to tell what type of function you're dealing with when it's written in standard form. Lastly, we have the constant term, and the constant term is the number that does not have a variable associated with it. So the 1 in this case is the constant term. So before we even get fully into multiplying polynomials and factoring polynomials, you'll need to be very clear on the different parts, how to write a polynomial in standard form. You will be tested on these things, and so you need to have a good working understanding of them. So as we move forward, we can take polynomials, any type of polynomial functions, and we can multiply them together. Now, as you learn to do this in Algebra 1, you probably learned how to deal with binomial expressions, which are terms that have two terms in the expression. So if you recall, we have a term where you can have one term, so 2x. That would be called a monomial. You could have something like x plus 2, and that would be a binomial. And then of course you could string that out to have 3 parts or 4 parts or 5 parts, and so forth and so on. What you may recall from Algebra 1 is when we multiplied something, we could multiply a monomial times a binomial, and this just required the distributive process, so it'd be x times x and x times 4. And that was just simply the distributive process. Then you may have moved up to something where you use the term FOIL. Now FOIL is just an acronym that gives us the order in which we want to multiply binomial expressions. And so if you remember multiplying binomial expressions, we had to take this and do it in a certain order. And you can see that the letters represent an ordering process in which to multiply by. Now, this is convenient when you're multiplying two binomial expressions, but it does not work for anything bigger than that. So if you're multiplying a monomial times a binomial, it's just a distributive process. If you're multiplying something bigger, it's still the distributive process, but it's convenient for us to use the FOIL terminology when we're multiplying two binomials. Now, what you need to keep in mind here is that this is simply still the distributive process, but we're going to be going through it twice. So if you look at the F and the O part, we're going to do the first part of each binomial. That's going to have me multiplying x times x. Then we're going to multiply the O part, which are the outer terms, which is the x and the 5. So if I multiply the x times the 5, what you recognize here is that I've simply distributed the x to the entire x plus 5. So I've done the distributive property one time there by doing the F and the O. Now, to continue the FOIL process, we are going to multiply the inside terms, and this has me multiplying the 3 times the x, and then the last terms has me multiplying the 3 times the 5. And if you recognize, what we've done here is we've done the distributive property a second time. So FOIL is just really a fancy acronym that gives you the order of distributing the binomial twice. So if we take a look at this sample problem, what I'd like you to do is take a little time, pause the video, and work sample problem 1 on your own, and then you can start up the video again to see the solutions. So go ahead at this point, work sample problem 1 using the FOIL method to multiply those two binomials. Okay, so if you did the sample problem, it should have looked something like this. We'll start with the distributive process of the x first, which is the F and the O of the FOIL process. So x times x is x squared, and then x times negative 1 is negative 1x. Then the second process is to distribute the 2, which gives us a positive 2x and then negative 2. Now, once I've distributed both parts and completed the FOIL process, it's important that I combine like terms. Now, understand that x squared and x are not the same terms, so you cannot combine those. The only terms that we can combine here are negative 1x and a positive x. So when we do that, that gives us x squared plus 1x minus 2, which is more appropriately written as x squared plus x minus 2. And that is my final answer. Now, a couple points about directions here. You could see something like simplify, or you could see something that says to multiply the polynomials, and they basically mean the same thing. So we're just trying to combine the two parts together, and we finish here with a 3-term polynomial, which would be a trinomial, and these are terms that you should be familiar with from Algebra 1. Now, that is when we're going to take two smaller polynomial expressions and put them together.